open up with any questions. You're getting those in the ENARSI module exams. There should not be any packet tracer items, Eric, in the ENARSI that I'm aware of. Run the system test for me, if you will. If you don't know what the system test is, just exam questions. Okay. Let me get in here real quick then. Let me jump into NetAcad. One of the things that you can do is run a system test for me. Get my chat up and running here. So if you go into our class, there should be at the top an item that says system test somewhere. I may not have it in these. Yeah, they don't have it in the CCNP. That's interesting. You do have it in non-CCNP classes. So if I go back up here and look at, let's see, it may not be in a network sec class either. Yep, there it is, system test exam. Try to take that, but you'll notice there's not one in our ENSA class. So what browser are you using, Eric? And when you say the exam questions, you're talking about literally these exams right here, the routing exams. Okay, so then have switched from Firefox. Yeah, Chrome shouldn't have any problems with that at all. Give me a screen capture on it if you don't mind. Eric, you are the first report I've had of anybody outside of a introduction to networks and a CCNA 1, 2, or 3 class has had any issues whatsoever. They've broken something somewhere in Cisco. They've broken it. Now I know there's supposed to be some. By the way, there's supposed to be some. If you ever need to know when there's going to be downtime, they always put them up here in these news and events. I don't think they've got anything else here now, but they broke something. Yep. Also, by the way, notice that there are updates to your legal documents, and that's the documents for your agreements. Let's see, students events. Maybe they'll tell us about it in the downtime. Nope, don't see it. Okay. That was February 24th. Well, I know they were trying to get a way to fix it and end up having a fix for us. But it so far has not been working in terms of what they tried to fix. I do have a neat little thing to tell y'all. Cisco's Instructor Training Center is a Premier Plus again. Okay, yeah, you're fine, Eric. You scored over 75%. Don't worry about it. You saw an issue with CyberOps. Okay, Damon. All right, and it was a same thing, just a blank question. You didn't see anything, but you went in and the question was blank. Run the system test for me, Damon. Run that system test and let me see what you're getting. See if it's hanging up. Okay, blank question. Yeah, I don't know what's going on. I don't know if there's some incompatibility between packet tracer and what they're doing or what. I just don't know. So they've definitely caused an issue with one of their updates. Real quick, folks, don't forget to do this quiz here, this non-NetAcad required items quiz. Able to move and reverse on exam of the question remains blank. Yeah. Try to, like I said, try to give me a screen capture of it on what exam it is, and what question it is, and then send that to me, and I will continue to forward that into. We have an open ticket, and then 3 other academies have open tickets with support trying to figure out what this is. So it's a known issue, and we're trying to get it fixed, folks. I apologize, but we are trying to get it fixed. So I want to talk today about BGP. No problem. Like I said, we'll do. My hands are kind of tied. There's certain things we can fix. There's a lot of stuff we can't fix. We try to update and put things in as fast as we can. But we've been working with this issue for over a week. Now, part of that is with the July 4th break. Obviously, there was some time when support was gone and all, but it's dragging on now and getting a little bit aggravating. I want to talk about BGP, and I want to talk about some items concerning BGP. Now, one of the things I will tell you about BGP is this. I call BGP the coffee cup protocol. And the reason I talk about it is because of the way BGP was designed. Because there are now over 900,000 routes in the BGP overall routing table for IPv4, you don't want a routing protocol that makes very quick changes at the flap of a single route, or if a route goes down, you don't want it reconfiguring everything. For that reason, this BGP was designed with a concept of not just triggered updates, but even what is called like a bounded update, to the point of where it will allow a group of updates to be basically put into a queue. And then when that queue timer expires, all those updates will go out. Now, you can force it by doing a clear BGP process. Be aware, in a production environment, that could completely hammer your network to the point that your routers would not be able to respond and actually move traffic. So be very careful with BGP out in the real world. It is a protocol that, you know, I used to joke about. You get the CCIE ring and you'd sit on the big chair, and people want to make changes to BGP. They had to come and kiss the ring before you would allow changes to be made. Yeah, exactly. If you make that mistake, there is a resume day update opportunity, because you're probably heading somewhere else. But I will tell you this: BGP, because of these mechanisms, is very slow to converge. Much slower than the interior gateway protocols we work with, OSPF, EIGRP, etc. So don't think just because you make a change and it doesn't immediately appear in the protocol, don't think that you've done something wrong. It could simply be BGP being BGP. Now, in a lab environment, we can clear the BGP process and force it to make the change and not worry about it. Just don't teach your students to do that in a real world environment, because, like I said, they will not be employed long. The good news is, rarely, if ever, are new employees allowed to actually touch BGP. It is such an important protocol, and we'll see why here in a minute. So we're going to look at some fundamentals, basic config, some behavior, and then look at multi-protocol support. We won't have time to get through every single bit of this today, but we're going to try to get through as much of it as we can. Now, BGP is a exterior gateway protocol. It is the only exterior gateway protocol that we now have available to us. There used to be a BGP or a protocol called EGP. We don't have that anymore. It is designed to connect autonomous systems. So an AS, remember, is a group of routers under the control of a single organization, typically running a common interior gateway protocol. When we take those autonomous systems and hook them together, we are probably going to use BGP. The other thing that's important is, with BGP, I want to pull something over. I want to show y'all. I'm going to pull over a quick thing here. So let me show you this. Okay, so I'm gonna pull this over. I know Cisco could gripe at me, they can gripe at me if they want, but I want to show you this. This is reasons for using. By the way, I bought the $1,000 Cisco ENARSI class. Bought it through my work. I didn't pay for it, thank goodness. But this is one of the things they talk about in their description of BGP fundamentals. I think it's an excellent picture here. Typically, we only use BGP if we are either multi-homed. So in other words, we have an autonomous system that connects to multiple ISPs, and we need to control that traffic going to those ISPs. Or we're a dual multi-homed, which is basically have two exit points and two ISPs, or single multi-homed, single exit point, double ISPs, or what's known as a transit AS. Now be aware, transit ASs are typically only ISPs. Now that's not always the case. You can have some large military or governmental organizations that may actually be a transit AS. But for the most part, those are only ISPs. BGP is a protocol that runs on TCP port 179. You must be able to have TCP connectivity between your routers in order to run BGP. You must also have reachability in order for a BGP peering session to take place. We then also have two different types of main BGP sessions. One is internal BGP. So that's IBGP routers that all exist within the same autonomous system. or they participate in what's called the same BGP confederation. We'll talk about that shortly. eBGP are sessions in between different autonomous systems. So if we were looking at our picture we just had here, okay, this AS6502, these routers inside of here would have iBGP peering sessions with one another. The connection between 65001 and 65002, that connection right there would be an eBGP, an exterior border gateway protocol connection, because it's between autonomous systems. So BGP is a path vector protocol, meaning that it uses a series of attributes to make the decision about which route is the best route to use. These path attributes can be are known as well-known mandatory, which means every single prefix advertisement must have it. A well-known mandatory you've heard of before is AS path. That has to be in every network layer reachability information that is sent out. Well-known discretionary may or may not be included with a prefix advertisement. And then there's optional transitive and optional non-transitive. And that is transitive means it stays with the route advertisement from AS to AS, or it can be non-transitive, which means it only stays within a single autonomous system. There are also some attributes that are not even sent between different routers. For instance, MED is a local item only. Now, if you look at this, I can actually take you over here. Let me show you something real quickly. I want to jump all the way over to 13 and show you a quick item here. It gives you a good understanding of path selection, because when we look at BGP, BGP makes a best path algorithm selection using these items right here. One is weight, and weight is a Cisco proprietary policy that is only Cisco defined attribute that is only important on a single router. So it's not going to be, it's not transitive. It doesn't move from router to router. Cannot be used to influence how other routers determine a path. It can only be used on a single router to determine the path. Higher weight is better weight. So then there's local preference, where did the route originate on the local router? What is the shortest accumulated interior gateway protocol metric attribute? That's a fairly new item that's been added. In fact, during my time working with BGP, this has been added over the last 15, 20 years. Shortest AS path, best origin code. We'll learn about those. It can basically be different types of origins for the route. Multi-exit discriminator. An external path is preferred over an internal path. Closest IGP, oldest EGP, and then it gets down to even the BGP router ID and the neighbor IP address. And we'll see what the router ID is, because it works very similar to what we've seen with OSPF router IDs and other router IDs. But I just wanted to show you those, because you'll see nowhere in here at any point was the speed of a link discussed. So none of that's used for the path vector algorithm that BGP uses. And that's very different from what we've seen before. All right, so let's roll on down here. So in order to have loop prevention, one of the things that BGP does, it does actually, I should have went ahead and did it. BGP does use the AS path as a loop prevention mechanism. In other words, by looking at the AS path, you can see whether or not it has gone through a particular autonomous system and see if there's possible loop. That is done with that AS path mechanism. So if BGP router receives a prefix advertisement with its AS listed in the AS path, it discards that because it thinks there may be a loop. Now, BGP is designed to run on both IPv4 and IPv6 now. That was through the use of multi-protocol BGP. So we do have the ability to do multi address families and sub-address families, so be aware of that. The other thing's a little weird about BGP is, first off, I want to explain to you that exterior BGP by default, eBGP, is designed so that, that's the wrong one, that's the CIDR report. my little different thing there. Yep, here it is. So this 6501 going to 6502 is an eBGP session. By default, eBGP expects your peers to be directly connected. Now, there is something we're going to learn about down, and you may have already read about it, probably have already read about it, but eBGP multi-hop. Okay, there is a way to make a eBGP session between two routers that are not directly connected, but you have to use a special multi-hop command to do that. By default, external BGP peers expect to be directly connected to each other. Now, inside of iBGP, so these inside of here, it's not as important that you have directly connected neighbors. So in other words, exactly, TTL by default is set to 1. So if you don't change that with that eBGP multi-hop parameter, it'll go 1 and then it will TTL out and that's it. So there's no way to form a BGP session. But you can actually increment it by more than 1 and then it can actually hop across. Exactly. Now, with interior BGP though, it is possible for you to be able to connect two devices that are not directly connected to each other, as long as they can talk to each other via TCP, and there is some kind of route from R2 to R4. Now that route could be a static route. That route could be a it could be a route in a interior gateway protocol. The only thing it can't be is a default route. Okay, that sounds weird, but BGP does not trust a default route to be a route that ensures that you'll be able to get to a peer. So just be aware of that. You cannot have a default route set up and use that as your reachability between two non-connected BGP peers. And the reason they use BGP peers instead of neighbors is, again, because they're not necessarily directly connected to each other. Now, this iBGP peering like this can cause some real issues we're going to see, and we'll see how we fix those with route reflectors and other things of that nature down the road. But just be aware, it is possible to do that. BGP uses a series of messages. One is open, used to set up the BGP session. The update is used to advertise routes, withdraw routes. Notifications are for some type of error condition with a BGP neighbor. And there is a keep alive, but that keep alive is not a broadcast. It's more of, it's a TCP connection. Be aware, I'm not going to go through this entire finite state machine, but BGP goes through a series of FSM states to get to an established state. If BGP is in idle, that's not good. That means it has not yet created a full connection to its BGP peer. Once you get to an established state, you have a full BGP established session. And if you see that, you can actually see using show TCP brief, you'll see that you have an established session on an ephemeral, that's a hard word to say, source port to the port of 179 on the foreign address and vice versa on the other. Okay. It is mentioned about 37 times that BGP uses TCP port 179. You're going to see that on the exam somewhere. There's going to be an ACL that blocks TCP. There's going to be an ACL that blocks port 179. That's going to be a troubleshooting item. Be aware of it. It's all over these slides. It's all over the book. Just be aware that you're going to see that more than likely. So what do we do when we're doing basic configurations? Well, first off, we're going to set up one thing. I will tell you this. These neighbor relationships are not automatic. All right. BGP has no ability to establish an automatic neighbor relationship with something like a hello packet. You have to manually configure the neighbor statements. So we're going to show you how to do that. We're going to look at how to verify it, and we're going to look at how we receive, process, and view route. So first off, we're going to initialize BGP with a router BGP AS number. Statically configure the router ID. Now, the router ID can be either a static ID that you put in, or it's going to be the same process for every other router ID we've ever found in a routing protocol. One, highest IP of an active loopback interface, or highest IP address of a active IPv4 address interface, or if there's none, you can't run out BGP. Okay. Now, if you change your router ID for some reason, let's say you forgot to put it in, and then you change it with the router ID command, you will need to reset your BGP sessions to get that to take place. Again, BGP is not quick about resetting things, so you may have to reset it manually by clearing your BGP sections. And then you also need to configure your neighbor and autonomous system number. So neighbor, IP address, remote AS number. Okay. Now, there's an optional step. You don't have to do this, but you can do it. You can actually tell it what interface you want to be the update source for your TCP updates. You're going to learn in a little bit about making the router ID a loopback IP address, putting those IP addresses into an interior gateway protocol so that you've got always have reachability inside of your interior BGP sessions or iBGP peers. You can do MD5 authentication using the neighbor IP address password under the parameters, and then you can change your timers if you want to. So let's look at a very simple topology here. Here's two eBGP peers directly connected. So they're in two different autonomous systems. Router 1, router BGP 65,100. Neighbor remote is 10.12.1.2. Remote AS is 65,200. You've got your password and you got your timer set. All right. And then you do the same on the other. Now notice the timer doesn't have to match, but they will use the lowest ones that are available in that setup. Okay. If you look at it, you can see show BGP IPv4 unicast summary. See our neighbor. We'll see the remote AS version 4, by the way. Number messages sent, received, state, preferred. Now this 0 is important. If you've got nothing there, that actually means you don't have an actual connection with your neighbor. There has to be some number in that state PFX RCD. So if it's blank, there's nothing there, there's a problem, something's going on. If it's a 0, you're good. You've at least got a connection. There's hadn't been any prefixes that have been received from your neighbor. Okay, so in this case, you've got a connection, but no prefixes have been shared between these two neighbors. Now you can then do network statements that allow networks to be advertised by BGP. This is the show BGP IPv4 unicast neighbors, and it's looked at the neighbor of 10.12.1.1. In this case would be this other router over here, a router 2's neighbor. And you'll see it says here, BGP neighbor is 10.12.1.1. The remote AS is an external link, so it's an eBGP connection. Remote router ID is 192.168.1.1. State is established. This is good. That means TCP is working and everything is hunky-dory. Hold time 40, keep live is 13. Okay. And then going on down through, it'll tell you the number of opens received, notifications, updates, keep alive. So it shows you all the things that have been received from the router. Now, BGP uses 3 different tables. It's called an adjacency rib in, and these are the NLRIs, or network layer reachability information, which are just prefixes that routes come in to this add rib in before inbound policies are processed. So in other words, before you do any type of route maps that would take a route out of a particular route table or keep it from going into the local rib. So this is what you received from your neighbors. Once that is processed and sent into the local rib, okay, the add rib in is purged to save memory. It's very important, especially because BGP, the route table is so big, they had to start doing ways to try to limit the amount of memory it uses. But the local rib now has all of the originating NLRIs that are local and any they've learned from their BGP peers, if they match and meet the next hop reachability check. In other words, there has to be, before anything goes in the local rib, there must be a way to get to the destination. Okay, so if I can't get to the next hop that's being advertised for an NLRI, it will not go in the local rib. and then it will not go into the route table because the contents of the local rib is used, the routing information base is used to actually create the IP routing table. After that, you got any of your outbound route maps, anything that's taking a route out of the, correct. Yep. Pretty much first BGP attribute. Yep. And then the add rib out, that is your routing information base that will be sent out to your peers. And that is after any outbound route policies are applied. So any of your route maps, anything that is for some reason pulling routes out of your BGP route table. So you use the network mask, subnet mask, and then you can do route maps if you want to, and use that to control some of the attributes. But that is to put networks into the local rib table that will then be advertised to your peers. Okay. So network statements identify a specific network prefix to be put into the BGP table. All right. And so you again see the network prefix can be now this is the main difference between BGP and other routing protocols that we've dealt with anyway. Okay. OSPF, you cannot advertise a network that you are not directly connected to. Same thing with EIGRP. In fact, there have been no routing protocols we've ever worked with to this point to where we didn't have a connected network that we would advertise. BGP can advertise a connected network, a secondary connected network, which is a secondary IP address on an interface, or any route from any route protocol. So in other words, you can actually take an interior gateway routing protocol, and as long as the router has a way to get to it with an IGP, even though it's not locally on this router, on a router, it will advertise it into BGP. That is very different than what we've done before. Right? Questions about that? Because that blew my mind when I first started learning about BGP. What's the key about that, though? What is the key in that advertisement of the connected or the static routing protocol? What's still the key? Quick question for y'all. What happens if I'm advertising a network on an interface for OSPF and I shut the interface down? What happens?
It's removed from the table.
It's removed from the table. Exactly, Eric. So really, when you think about BGP, although it's super weird that it's advertising routes it's learned either from a static route or from a routing protocol, it still must have a way to reach the route that it's going to advertise. If for some reason that route was to be removed from the static route, or it drops out of the dynamic routing protocol, the interior gateway protocol, it will no longer be advertised by BGP. Still has to be reachable. Okay. So here we have an example. 11.5 R1 has multiple routes learned from static routes, EIGRP and OSPF. R3's loopback was learned through EIGRP, R4's static, R5 via OSPF, and it advertises all of those into BGP. Okay. Now, if for some reason those were removed from those, either static, EIGRP, or OSPF, they would also no longer be advertised out to R2. So you'll see here, not every prefix in local rib is advertised or installed in the global rib. By default, only the best route is placed into the routing table. Okay. It must pass that valid. It must pass the validity check, the next hop validity check, and then it will only pass the best path. Now there is a way to do multi-path. We'll talk about that in a little bit in a couple chapters, but it is possible to do that. Now here's an example showing the routing table, actually showing the BGP routing information. If it is a star and then the little greater than sign, that actually means that's the best route. That's the route being used. Okay. So star alligator mouth is the best route. And you know that R2 is learning all these strictly from eBGP, so all it sees is the MED, the metric and the origin code. So R1 learns them from different parameters here via OSPF, or this one it says it's redistributed in OSPF, so it doesn't know. That's internal. Okay. Or IGP. So it says it was learned from IGP. That was learned from IGP. For some reason, it couldn't understand the redistributed from OSPF, so it thinks that's an incomplete. Doesn't know. Okay. So in our item here, we'll see list of network prefixes that are installed. Next hop, that is a mandatory BGP attribute. Finds the IP address of the next hop. MED is, or metric is also known for MED. That is an optional non-transitive BGP path attribute. It can be used to determine the best on a single router to make that router determine where it's going to send certain traffic. Local prep is a well-known discretionary BGP path used inside of iBGP, so it will be passed within an autonomous system. And we'll talk about weight, locally significant attribute that is used, and then path and origin. All of those are different types of BGP fields that we have. All right, let's move on down. So here's our rib table showing out verifying routes. Notice here the number again, it's as long as it's a number, you're good. If that is blank, you don't have a fully established session. You need to go check to make sure you have connectivity between the two BGP peers. So let's look at internal BGP versus external BGP. We've already talked about this a little bit. BGP sessions are always point-to-point between two routers. iBGP within the same AS, eBGP between different ASs. This particular instance, this 65200, is what's called a transitive AS. Now, where you can get into serious trouble out in the real world, okay, is this right here. If you are a dual multi-homed AS, in other words, this is your company and you're doing this so that you have multiple paths to different ISPs, or you're single home multi-AS, you never want to let it get set up where these ISPs can use you as a transitive AS. That can destroy certain networks, because suddenly ISP1 would see that you were available to route traffic through and would start routing all of its traffic or some of its traffic through you to ISP2. So in these cases, you want to be very careful when you're doing multi-homed autonomous systems that you don't set anything to be transitive. A transitive AS will only be an ISP. Or, again, it could be a very large organization that, for whatever reason, has multiple autonomous systems, like the government. So, iBGP sessions, okay? So R2 could form a session with R4. R3 would not know how to route traffic from AS 65.1 or 65.3 because it does not get the routing information from them. So you'll notice that the BGP routes for 1045.1 are being shared between R2 and R4, but they're not being shared to R3. Now we're going to learn about some reasons you'd want to do that. Part of that is you may be tunneling through this network. That internal router may not be able to handle the 800,000 IPv4 prefixes. It's actually over 900,000 now. Correct. Yep, Eric, you got to make your routes, make sure they are not transitive. Yep. Prepend them, and also just make it where they don't look like a good route. You don't want it to come through your network. Now, one of the things that, in order for iBGP to really work correctly, in other words, an iBGP peer will not advertise routes it learns to another iBGP peer. So if you have an autonomous system and you really want full reachability, you have a full mesh requirement, which is R1 must have a an IBGP peering with R3. R2 must have one with R1 and R3. Now we're going to learn about route reflectors, because if you had a large transitive network and you were doing internal BGP, and well, even if it wasn't transitive, if you just had a large internal BGP network, an autonomous system, the number of peering sessions you would have to have could become enormous. So we're going to talk about a way to fix this by using what's called a route reflector. So by default, though, if R1 and R2 have a peering and R2 and R3 have a peering, the routes that R1 tells R2 will not be sent automatically to R3. You would have to have a peering session from R1 to R3 for that to take place. Exactly. Eric makes in chat mentions n times n minus 1 neighboring peers, so you can end up with a crazy number of connections to those peers. Now, peering can be done with your real IP addresses, or it's actually more of a best practice to do it to loopback addresses. So in other words, if you're doing peering across a real link, well, using the IP addresses of that link, and that link goes down, you can lose your IBGP peering. So you could add a second pair of links, and all those links would become the ones used for your IBGP peering. That just is crazy. It adds way too much to your setup. A better thing to do is to create a series of loopbacks, advertise those loopbacks into your gateway protocol. So as long as it's reachable, you can use it as the peering endpoint for your IBGP peers. So you can see here, we've got on R1, we tell it neighbor 192.168.22 update source loopback 0. So it's going to use the loopback 0 for its two neighbors, and vice versa. R2 is going to do the same thing. And then we're going to advertise those into OSPF. So in other words, we're advertising our, in this case, network 192.168.11 quad zeros, area 0. That would put the loopback into area 0. So we're each router will advertise into the interior gateway protocol its loopbacks, and then those are used for your peering sources and for your neighbor source. So that would 2.2 would be a loopback on router 2, 3.3 would be a loopback on R3. And all of those would be reachable through OSPF. So if this link actually went down, OSPF would just create a redundant route going the other way, and you would never lose your BGP peering session. Now, eBGP is that external BGP, which is between autonomous systems. By default, the TDL is 1, so you must be directly connected. You can fix that using eBGP multi-hop. So you can do that. You can go all the way up to 255, which will be a very long ways away, but you can do it. Now, you look at some of these sessions here. Just look at figure 11. You can see that we've got our eBGP and our IBGP inside of here. There could be, now in this particular picture, there is not another router between R2 and R3, but they could very well be. So just remember that we need to be able to have that next layer reachability, that next hop, and that cannot be dependent upon a default route. So we're doing that. Actually, I'm gonna blow through that right through there. Just kind of. Here's a way that we can fix some issues that are going on. You see it's missing a prefix because it didn't pass R2's next hop accessibility check. So it shows the BGP for R3 is 32 prefix. It's not advertised because the next hop is inaccessible. You can use a technique to ensure the next hop address check passes without advertising it by using next hop self. And that basically modifies the next hop in the NLRI, and it can fix some of these next hop reachability issues. The other item here is when we talked about our peering, all those n times n minus 1. If we do not want to form all those peer sessions, we can, by the way, a full mesh topology of 10 routers will require 45 sessions, TCP sessions. They introduced this thing called route reflectors. So a route reflector can take a route that comes in and from a BGP peer that is not a peer of another client, and it can reflect or send that to the BGP peer. So in other words, if a route reflector receives a network layer reachability from a non-route reflector client, the RR advertises it to an RR client. It doesn't advertise it to non-RR clients. So a non-RR client sends out a route. The route reflector will send that to a client. Okay. Now, I won't send it to a non-client because it's going to believe, if it's a non-client, that that client already has a peering session with the other BGP members of the autonomous system. Okay. If it receives network layer reachability from a route reflector client, it's going to advertise it to everybody. But of course, that client is going to ignore it because it came from the client. So it's going to use split horizon and say, well, I told you about that, so I'm not going to listen for you. Sends it to everybody. If it receives a route from eBGP peer, it advertises that to route reflector clients and non-route reflector clients. So in this first instance, the reason it does not advertise it to the non-route reflector client is because if you set it as a non-route reflector client, it is assumed it has a session with all other BGP internal peers. But this, if you set it up correctly, you don't have to have a peering between every single router. You can say there's a peering between 4 or 5 very important routers in your autonomous system, and then use route reflectors to make sure that the BGP information gets to your other clients. And you can set it up just like this. You can say that a neighbor is a route reflector client on a particular setup. So in this case, with our network we have here, we have iBGP sessions between R1 and R2, between R2, R3, and R3, R4. But R1 doesn't have one with R3, and R1 doesn't have one with R4. So we've set up R2, sets up the R1 to be a route reflector client. So anything that comes in, it will go out to that route reflector client. Likewise, R3 will set up R4 as a route reflector client, so that it will send that out there. So R2 and R3 become route reflectors, and they ensure that all of the BGP information gets between the peers. And that saves you from 2 BGP sessions on R1 and 2 BGP sessions minimum on R4. Okay. Now, that's only for internal BGP. So here we see it again, route reflector. Normal IGBP connection comes in, the R2 will send it out to all the route reflectors and the non-route reflector clients, just like we talked about up here. So our rule is, if a route reflector receives a network layer reachability from a non-route reflector client, it advertises it to the route reflector client. It does not reflect to non-route reflector. If it receives it from a route reflector client, it advertises it to everyone. So in this case down here, it got a normal iBGP set of information, this 10110 from R1, but R2 sees that as a client, so it sends it to everybody, both route reflector clients and non-route reflector clients. You'll notice R2 and R3 have a normal internal BGP peering session. Now, with route reflectors, there were 2 route reflector specific attributes added to prevent loops. One is originator ID, optional non-transitive, and then this cluster appended to the route reflector was cluster ID. If it gets one with the cluster ID and cluster attribute, it is discarded. So in other words, if it's part of a cluster and it sees that attribute, it will drop it. Same as if it sees it's written the originator attribute, it will drop it because it will think that it's gone all the way around a loop back to it, or if it's in a cluster, it's gone around a cluster and come back to it. You also can fix the same issue using confederations. And with that, basically you create a member ASN, create configuration. Routers that directly peer with another member AS identify the peering AS with the BGP confederation. Now, what happens with these confederations is inside the confederation, they will share the information, and then you can have the information go between confederations. Okay. So this is your confederation of 200, and their peers are 65, 200. So confederations, they can be used within members like normal. It is just another way to handle that internal BGP problems. And we'll talk a little more about them as we're running out of time. Let's jump on down. But it is another way to handle that IBGP peering problem by creating these confederations, share information within inside of them. Then you can use route reflectors inside of those. You also can have the confederations share information to one another. So you know it's AS200, you've got two confederations inside of here, which are seen as two separate ASs. Now, last but not least, we do have support for IPv6. It runs basically the same. We got to go on down here. I'm not going to do a whole lot of looking at it. Look at the configuration. The only difference is we now use address families. So we do router BGP, we put in our router ID, we put in our neighbor addresses. It says no BGP default IPv4 unicast. We're going to be using IPv6, and you activate the neighbor and interfaces, and then put in your networks you advertise. So not very different than the other. And the last but not least, that was in the next section. Okay, that's actually it for this particular chapter. Questions about basic BGP. Have you run into any major issues on the labs with BGP that's giving you trouble? No major issues. By the way, I did catch up on grading yesterday. Now, obviously, I will be behind after today because some folks have turned in stuff today. But I was caught up as of yesterday. So, all righty. Well, folks, we are at, let's see, right in here, working on labs 11, 12, 13, 14. Those are the ones you're working on. Next week, I will not be able to meet class. I'm going to be out of the office the entire week. So we will not have class next week, but we will have it the week after. So I will be canceling next week's class. Just be aware that we will have class the following week. Questions? Everybody's good to go? Stop the recording.